Hey everybody. I'm gonna be in the corner in case you want to look down, like down here. Um, Welcome to our first lesson of physical science, and this is also my first attempt at a legit screencastify. So we're gonna talk about what is science, because I've noticed that there is, in teaching this, there's no point really to get to content until we talk about what is it we're even doing. So science and math started first. Math and astronomy are really the first sciences, and discovering our world in geology and geography of measuring the earth. And then from that sprang a way of thinking to try to determine things, which is called the scientific method. So I want you to read this website. I'm going to link it in our thing also, but I'm going to read it here for you and follow along about what is science. So if we're starting up here, science is a systematic and logical approach to discovering how things in the universe work. It is also the body of knowledge accumulated through the discoveries about all the things in the universe. So basically that's just like we want to know everything, but we need to be clear about it. The word science is derived from the Latin word, because that goes back to the history of who we are, scientia, which is knowledge based on demonstrable and reproducible data. Reproducible, meaning we can do it again and again and again and again. What's happening now, sidebar, with COVID, maybe you're reading ahead, is that we're trying to find a vaccine, right? Maybe you've heard about this with COVID. And there are trials, and you have a set number of people for the trial. Let's say it's 100 or 1,000, and people volunteer for this. I know of people in New York who were in COVID trials. And then you're studied. What happened to you is studied. And then sort of the antidote, which we're calling a vaccine, is then put together. So we want to make people whole. So you have all these jagged edges which make you sick, and then it's almost like trying to fuse in between to create the vaccine. But we have to figure out what this is. So lots of people are studied, how they got sick, what happened, and then they're given trials of different kind of medicines. Those are compounds, which is chemistry, and Maha can teach you that. But what's happening is that you can't just do it once and call it done. Oh, it worked once, we're done. No. You do 1, 2, 100, 1,000, and the more it's done with the more positive outcomes, then that's when we say, okay, now this is something that we can rely on and we can reproduce. Okay? So you see my cursor here, I'm not going to read all this. I just want you to know it's demonstrated, that's demonstrable, that word right here. I don't know how to highlight on here. And it can be reproduced again, reproducible. That's where like a vaccine for COVID is coming from. Okay? So maybe hopefully you read the rest of that. The scientific method, so now I'm at the top of this next one. When conducting research, scientists use the scientific method to collect measurable empirical evidence, meaning something you can see. And if you need to, a link in this website, you can click on this link and it'll take you to what you need for that. Ignore the ads. In an experiment related to a hypothesis, okay? And this is in math, geometry, if-then statements. The resulting aim is to support or contradict a theory, okay? And that's what I was talking about with like COVID, sidebar. You can read this I'm only going to read that section. So we have an idea that an antidote or a vaccine exists. The reason we think that, so ancient civilizations, 1,000 years ago, the coronavirus would just wipe out half the population because everyone just got sick and died, and humanity didn't know what to do. That's when they called it the plague. But now we see this thing, right? COVID-19. And we say, oh boy, we have, as human beings, as scientists, we have proven to ourselves that we can come up with vaccines. We have a measles vaccine. We have a mumps vaccine. We have a polio vaccine. We have a chickenpox vaccine. You probably got those when you were a child. So we know we can get vaccines. So now we say, okay, so our theory, I'm going to highlight in the right, is that a vaccine exists. Now we're going to make a hypothesis as to what that is and how we get there. And then we do testing. We're living out a biological, chemical, scientific method right now that the whole world is seeing. And I don't know if you know this, but there are two companies that have come up with what appear to be workable vaccines. And now they're going to different government agencies and saying, here's our trial. This is what works. Will you say this is okay so we can give it to trial like large amounts of people? That's where we are. Okay. I'm going to skip this too and scroll down. All right. We're going to the real stuff. Okay. So this is really important. The steps of the scientific method. Okay. Make an observation. Number 2, ask questions. Number 3, form a hypothesis. That's your thinking. You are the one who comes up with the hypothesis. Okay? So you're seeing something, like right now I'm looking outside. I'm seeing, since it snowed yesterday, the snow has not melted. So it must be below 32 degrees because I know 32 degrees Fahrenheit is the place with which water goes from a solid to a liquid, or from ice to water, snow to water, right? But it hasn't melted, so I'm making an observation. I'm questioning, why is there white snow still on the roof of my neighbor's house? And then I go, it must be below 32 degrees. Even though I'm in a nice, warm 70-degree house, that's my observation about outside, okay? Now, number 4 is test the hypothesis. Well, I can test that by physically going outside and seeing my breath, because that also indicates that it's below, because that means that your breath is becoming the moisture in your breath is becoming a solid as it leaves your mouth. It's kind of neat. And then I can also test it with a thermometer, but before those things existed, that's how we would test. I could also test by taking a glass of water, filling it up from the tap, setting it outside. And in fact, that's what I'd like you to do. Analyze the data and draw conclusions. So the conclusion then, if I poured out a glass of water from my thermos or my faucet, and I set it outside and give it a set amount of time, right? Maybe an hour. Probably don't even need that much, but let's just say 15 minutes. Okay. Then you take it back in, and if the water's turned to ice, then you know that your hypothesis was correct. Okay. So that's number 5. Analyze the data. The data would be the frozen cup, and draw conclusions. Okay. And then you can accept or reject the hypothesis. In my water case, I'm accepting it. Okay. Then reproduce the experience until the experiment, this is number 6, until there are no discrepancies between the observations and the theory, which means to say, just trying to freeze 1 cup of water is like, I should try to freeze another cup just in case. And I'm going to do it I'm going to do several of the exact same size and the exact same volume of water, but then I'm also going to place different things in other parts of the yard, right? Just to be clear. And then you would graph a table or make you write down. This is why it's so important to communicate. You're writing down what you're seeing, okay? If someone came up with the COVID vaccine and never wrote it down, that doesn't help any of us. Okay, here's a little extra I would like you to read, right? The hypothesis must be testable and falsifiable, meaning that you can test it and you can determine if it's going to be true or untrue, okay? Sometimes people pose questions. This has become very clear on social media that I noticed that people don't understand logic. And this is logic. The scientific method is deductible logic. That's why math and science are so linked, because math is just the theory of logic, and it proves so much of science. And then science is like, okay, now let's get into the physical world. What is that? Versus math is very much up here. So you have to be, it has to be something that can be true or false. The way the question is posed, the hypothesis. People put a lot of things out there that they're not hypothetical. They're theoretical in the sense that it's like an idea that you'd like to have, but you can't possibly test it. For example, if we all lived outside, then no one would ever be sad again. Well, how do you tell someone's emotional state? And also, how are you going to get the entire humanity living outside? It's just, that's not testable. It's too large. And you can't possibly quantify someone's emotional state because people say things that aren't the truth. People will deny that they're sad if they are. Then now you have psychology involved, which isn't necessarily the scientific method. So that's why it must be testable and falsifiable, meaning it has to have a place that is like true, not true. Okay? It must involve research and deductive and inductive reasoning. And we talk about this a lot in math class. In geometry is when this kind of reasoning comes out, which I love teaching geometry. So it's like you can deduce it, like I was talking about that. And the first thing before I deduce the cold by the water freezing, I'm getting inductive reasoning by I'm already observing something I've seen before. Okay? So, I want to point this out. This is good to read the rest. I'm not going to read the rest, and I'm not going to, I do want to read the history of science, and that's going to be the next screencastify. So we're going to get to here. But I'm not going to read that next section. It's just kind of a sidebar about different emotional states of science. And that's also, that's a legitimate thing. So that is the first lesson. I'm going to ask you a few questions about what we just went through. And I want you to consider freezing some water. The colder it gets, when we've had polar vortex, this is true, but I would love, if it gets to a cold state, I can't create the state of the world right now. Water will go actually from water, melted liquid water, directly to vapor. What I was talking about, what happens when you breathe when it's cold. It'll go right through the solid state of ice into vapor when it's super cold, which is pretty incredible. But we can't do that right now because I think it's like 18 degrees out, but it has to be like -20 for it to do that. Okay, the next lesson will be this one, A Brief History of Science. And then we'll have a worksheet on that also. So stay strong in COVID, and I'm thinking about you.